Are you curious about how data locality impacts your work with AWS, especially when using S3 and EMR? If so, you're in the right place. Today, we're diving into the importance of data locality in cloud computing and how it affects your MapReduce and Spark jobs. I totally understand your concern. Many users feel anxious about data locality when transitioning to cloud services. It can be a real challenge to ensure that your data is processed efficiently, especially when using S3 with EMR. Let's look at your specific question. You mentioned that you're considering using S3 with EMR instead of EC2, and you're worried about how data locality will affect your jobs. You want to know how significant this issue really is, and if the benefits of S3 outweigh the potential drawbacks. So what exactly is data locality? In simple terms, it's about keeping your data close to where it's processed. When using S3, your data is stored separately from your compute resources, which can lead to delays as data is pulled into HDFS for processing. But don't worry, there are ways to manage this effectively. Stay with me. By the end of this video, you'll have a clear understanding of how to optimize your data locality strategy and make the most of your AWS setup. To address the user's concern about data locality with S3 and EMR, the first step is to understand how data is accessed during processing. When using Amazon EMR with S3, the data is stored in S3 and accessed over the network. The user should consider that while the initial job will require pulling data from S3 to HDFS, subsequent jobs can leverage the intermediate results stored locally. This means that the impact of data locality decreases after the first job. Next, the user can optimize their workflow by using Amazon EMR's features. For example, they can configure the cluster to use instance store volumes for temporary data, which can speed up processing. Finally, the user should monitor their job performance. By analyzing the execution times and resource usage, they can determine if the data locality issue significantly affects their specific use case. Fun fact, did you know that the concept of data locality was inspired by the way we prefer to shop? Just like we like to grab items from nearby shelves, computers also perform better when they can access data close to them. Now, let's look at the answers provided by other users. An alternative approach shared by another user highlights that EMR does not actually pull data from S3 to HDFS. Instead, it utilizes its own implementation of HDFS support directly on S3, allowing you to operate as if you are using HDFS. Additionally, this user points out that S3 is considered rack local to EMR Spark clusters, which helps address concerns about data locality. Let's move forward and look at another answer. One user points out that using EMR with S3 and EMRFS does not maintain data locality, which can be a drawback for analytics processing, especially with SQL tools. They suggest that Redshift might be a better option for scenarios where compute and data are co-located. For more insights, they recommend checking a specific time frame in a linked video and also refer to a blog discussing the performance of S3 versus HDFS. Additionally, they suggest consulting a book on programming Elastic MapReduce for a deeper understanding. Here's a pro tip. If you're concerned about data locality, consider using Amazon's Glue or Athena to query data directly from S3 without needing to pull it into HDFS. This can save you time and resources. And there you have it. Understanding data locality can help you make informed decisions about your AWS setup. If you found this video helpful, please subscribe for more insights and tips on optimizing your cloud experience.